All right, guys, I just wanted to do a quick recap on what we touched on in class today. You will need your book open to kind of follow along with what we're doing here. Section 2.6 starts on page 136. And then today in class, we talked about our properties of real numbers. You have a graphic organizer with all of these on them at this point. We talked about some of these properties of equality also have properties of congruence. We're going to use that in what we're going to do this evening. We talked about how to do an algebraic proof, and we went through a few examples together in class, and then we worked a few on our own. So what I want to talk about with you this evening is moving towards a geometric proof, a formal proof, or a two-column proof is what we're usually going to refer to it as. And really, we already have started our introduction to two-column proof with this algebraic proof that we did today. All right, the very first one that we looked at, hey, we've got statements and we've got reasons. Okay, this is what a two-column proof looks like. My first column is my statements, my second column is my reasons. Okay, so even though it's algebraic in nature, it's still structured in a formal two-column proof format. Okay, so we're going to be using this same format for our geometric proofs moving forward, where we have statements on the left and reasons on the right. Okay, so our statements are the items that we include in our argument. They are claims that we believe to be true. The reasons are going to directly correlate with each statement. Okay, so if I have 5 statements, I need 5 reasons. If I have 10 statements, I need 10 reasons. I'm going to have a reason to justify every statement. The reasons are going to be properties of equality, properties of congruence, definitions, theorems, postulates. My statements are my thought process. How am I going about proving what I'm being asked to prove? Okay? So moving forward from algebraic to geometric proof, and this is kind of a modge podge of the two. Moving forward, it will be more geometric than algebraic, but what we're going to be doing tonight is kind of a mixture of the two. You have a geometric concept, but you're going to be more or less constructing an algebraic proof using those algebraic properties that we talked about today. Okay, so this is what I mean. We have a geometric concept here where we've got angle FGJ congruent to angle GJK. So we're talking about this angle and this angle. Sorry, FGJ, and JGK. So this angle and this angle are congruent. So we can make our little tick marks there. JGK is congruent to KGH. Okay, so all of these are congruent to one another. Okay, so this angle is equal to this angle is equal to this angle. We want to prove that x is equal to 6. And we want to write a two-column proof to prove that. Okay, and here's your given information, which you're always going to be provided with. Okay, and that's just what you were given up here. Okay, these angles are congruent, and then they also give you the measures of the angles that were listed here in your figure. Okay, and then you're also going to always be given what you want to prove. Okay, this is always going to be your first statement, and the reason is always going to be given. This is always going to be your last statement. Whatever you've been asked to prove is always going to be your last statement. Okay, so those are two things that will never change. Your given is always your first, your prove is always your last. So let's take a look at how we go about proving this. Okay, here is your proof of that particular situation. Okay, as I said before, this is always going to be your first statement. All of the given information. Whatever they give you, you're going to list all of it. And then the reason for that is going to be that it was given to you. Okay, so more often than not in this type situation, when I'm asked to prove that something the value of something. In this case, I'm asked to prove that x is equal to 6. I've got to first get out of congruence and into equality. Okay, there is a difference between those two things. Okay, so if you'll notice in our first step here, we took those congruent statements and we changed them to equality statements. Okay, and it went from just being an angle to the measure of an angle to the measure of an angle, measure, an angle to a measure. Okay, that's the difference between the two. This is talking about basically the shape of it. This is talking about the numerical value associated with it. Okay, so I have to first change this from a congruent statement to a statement of equality, and I do this using the definition of congruent angles, which states that if angles are congruent, then they have equal measures. Okay, so now that I have all of these set equal to one another, now I'm looking at, okay, what's the equation that I need to be able to solve for x? Well, in this particular figure, I had this angle measure and this angle measure defined in terms of x, so I can set them equal to one another. Okay? I know that these two are equal by the transitive property. Right? This would be if A is equal to B and B is equal to C, then A is equal to C. Okay? This is the transitive property of equality. That's what allows me to set these two equations equal to one another. Okay, why would I want to set these two angles equal? Because they're the ones that have been defined in terms of x. So now that I have the angle measures set equal, I can substitute those expressions in terms of x in for the angle measures. And from this point, it's an algebraic proof. Okay, so that's why I said it's kind of a Mod Podge. We're kind of combining two different concepts here, because the first three steps are geometric in nature, but once you get this set up, it's an algebraic proof from here on out using those properties of real numbers. Okay, so then we're going to isolate our variable by adding 5 to both sides. That's your addition property of equality. Then we're going to substitute. So you've got to show your work and then do your work that we talked about today. So addition property and then substitution, because I'm substituting 7 plus 5 with 12, and I'm substituting negative 5 plus 5 with the 0 that's not written here. Okay. Then after that, I use my subtraction property of equality. Okay, and then substitution again, because I'm substituting 8x minus 6x with this 2x. Then your division property of equality to get your coefficient of 1. Then substitution, because I'm substituting this with x, and I'm substituting 12 divided by 2 with 6. All right, and then my last statement, which is kind of blocked down here at this point, my last statement is that x is equal to 6. And that's what I was asked to prove. And like I told you, that will always be your last statement. Okay, and also notice the tediousness here, where I've got, here, let me scroll down a little bit so we can see this. I won't be able to. So notice the tediousness here, that I was asked to prove that x is equal to 6, and by virtue of the way that I solved the equation, I ended up with 6 is equal to x. Okay, well, that means that now I've got to switch this back around. Okay, I can't just switch it without giving a reason for it in the context of a formal proof. So if the x was on this side, I can't put the x on the other side without a reason for it. Okay, so 6 is equal to x is the same as x is equal to 6, and the reason that I'm allowed to do that is my symmetric property of equality. So it's very important that we know these properties and understand these properties in moving forward doing these proofs. All right, so let's do a couple more of these together. We are on page 138 in your textbook now, looking at guided practice 3A. And we've been asked to prove, if angle A is congruent to angle B and the measure of angle A is equal to 37, then the measure of angle B is equal to 37. Okay, in this particular problem, they didn't come out and say what your given was and what you're asked to prove. But what we do have here is called a conditional statement. When you have a conditional statement, the if, what comes after if, is what you've been asked to prove. What comes after then is what comes after if is your given information. What comes after then is what you've been asked to prove. Okay, so my given here is what comes after if. This is my given. So I'm given that angle A is congruent to angle B, and I'm also given that the measure of angle A is equal to 37 degrees. What I've been asked to prove is that the measure of angle B is equal to 37 degrees. Okay, so as always, my statements go on the left, and this is the way you'll need to set this up. You'll need your little cross and 2 columns with statements on the left, reasons on the right. My first statement always is whatever my given information is. However much or however little given information you have, that is always your first statement. So I have angle A congruent to angle B, and I have measure of angle A equal to 37 degrees, and the reason is because it was given to me. I know that because it was given. So very similar to the last one that we looked at, I want to get away from congruent statement and move towards a statement of equality. Okay, so that's going to be my first order of business, is I want to say that the measure of angle A is equal to the measure of angle B. And what allows me to say that is the definition of congruent angles. And shorthand is going to come in handy on these proofs because you're not going to have a lot of room. So as long as you abbreviate in such a way that I'm able to understand what you're saying, I'm perfectly fine with abbreviating and shorthanding things. Okay, so now that I have these two things equal, how does this help me? That's always what you need to be thinking to yourself, is why am I doing what I'm doing? So how does this allow me to move forward in getting to answering the question that the measure of angle B is 37 degrees? Well, if these two are equal and this one is 37, then now I can substitute this information in right here. Okay, I know the measure of angle A is 37 degrees. This is no different than substituting a value in for a variable. Okay, something like if I had x is equal to 5, and then I had some statement that said x equals y, okay, then I can plug in 5 for x, and I know that y is equal to 5 also. All I'm doing here is taking this and plugging it in for x. It's a very similar concept what you're doing here with this angle measure. Okay, technically that's a variable. The measure of angle A is technically a variable that's been defined. So I'm going to substitute this and my reason for this is the substitution property of equality, which I'm just going to abbreviate with subs. Okay, well, again, it's very tedious, these proofs are, and I've been asked to prove that the measure of angle B is equal to 37 degrees, not that 37 degrees is equal to the measure of angle B. So very similarly to the last proof, I need to flip this around. Measure of angle B is equal to 37 degrees, and what allows me to do that is the symmetric property of equality. Okay, and POE is what I will use for property of equality. That's kind of my abbreviation that I'll use in class and in our examples. Okay, let's do one more of these, and then we'll be done with this video. Okay, same deal here. I have an if-then statement. So what comes after if is what I've been given. What comes after